So in this video, our quest is to find the values of the current I1, I2, I3, and I4 in the circuit. The first thing we have to do is to assign polarities. The current flows through this place, so we say plus, minus, plus, minus, plus, minus, and okay, plus, minus. Yeah, already assigned. And the value of V naught, we'll be finding I1 through I4 and the value of V naught. So first thing we do is to write the KCL equation. We can only write one KCL equation here because we only have one essential node. This is basically a return node, so we can say that KCL, so 10 amperes is entering and the other currents are leaving. So we can say that 10 equals I1 plus I2 plus I3 plus 2 plus I4, which means that I1 plus I2 plus I3 plus I4 equals 8. Let's call this our first equation. Then we can write KVL in this loop. KVL, let's call this loop 1. KVL loop 1, and that will be 20I2 minus 10I1 equals 0. Our second equation. Okay, come to this loop. Let's call this our loop 2, and then KVL in loop 2. KVL loop 2 would be 30I3 minus 20I2. 30I3 minus 20I2 equals 0. Call that the third equation. We need one more equation, and we can easily write that by visualizing the circuits as something like this. So we can write a KVL in this loop, and then you have KVL loop 3b 60I4 minus 30 I3 equals 0. Okay, so we have 4 equations. We can solve this simultaneously. So to do that, we know that from the fifth equation, I3 equals 2I4. Let's call this our sixth. We can substitute this in the first equation. If we do so, we have I1 plus I2 plus I3 plus 2 plus I3 all over 2 equals 8, which can be written as I1 plus I2 plus I3 plus 1.5 I3 equals 8. Then we can solve, we can call this our seventh equation. Call this our seventh equation. We can solve it simultaneously with the second and and third equation, and that will give us our I1 equals 4, I2 equals 2 amperes, and I3 equals 1.33 amperes. This will infer that I4 would be equals to 2.66 amperes, and then V0 would be equals to 20 times I2. Say if you want to take V0 here, because this circuit is in parallel, so the voltage drop is the same across each resistor. So you can simply say that V2. So you can say V2 is equals to V0, which is equals to I2 times 20. Now we recall that I2 is equals to 2 amperes, which means that 2 times 20, so equals 40 amperes. So V0 is equals to 40 amperes.